Thank you for joining Exploring the Artistic Frontier, Unleashing Creativities in 3D Models with glTF and PBR. Our presenter today is Eric Chadwick, a senior 3D technical artist. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this webinar and we'll share the link along with the slides and the recording this week. At the end of the session, please complete the short survey form to help us better design future events. With that, I'll hand it over to Eric Chadwick. Eric?
Great. Thanks, Jeff. Let me share my screen here. All right, great. So here's a preview of what we're looking at today. We'll discuss how these were made with new glTF extensions and extend the PBR material features. My presentation will be about 30 minutes, and then we'll have a Q&A session. So a bit about me. My team builds the pipelines for optimizing 3D assets at GGG, and a significant part of my role is developing materials and workflows for creating 3D assets like these, both pre-rendered and real-time. I just started here at DGG, and I have a game development background. I'm also admin over at the Polycount Forum, which is a great place for CG artists to get together. And I curate the wiki there on the site as well. So here you can see some of the assets I've made, part of developing new features for glTF, creating tutorials and figuring out workflows. And then today, we'll be dissecting two of these. There's an abalone shell here with thin film iridescence and a brushed copper lamp with anisotropic reflections. So a bit about the Kronos Group. These assets were made as part of my involvement in developing open source standards. I've worked with the Kronos Group since 2017 in these weekly calls with industry leaders. You can see some of them here, working together to solve common problems that we all have in generating 3D content for e-commerce at scale, right? It's a hard problem to solve. So let's dive in. This is a glTF model of an abalone shell, and it's using the new material extension for glTF that creates thin film. It's called KHR Materials Iridescence. As you can see here, it creates these interesting camera relative reflections and colors. And we'll dive into exactly how this was made. So I started with a photogrammetry asset that was made by Abby Crawford over at Sketchfab. And there's a lot of detail here. And with photogrammetry, you typically only have a diffuse texture, but you do have a lot of polygons. So that's always really helpful. But for making it for glTF, you want to reduce that down to make it a more efficient kind of surface and better for shading and everything. So in 3ds Max, I used the retopology modifier. That's the default settings here. All I had to do is press compute, and automatically it gives me a really nice flow with less than 10,000 triangles, which is great. And then the UVs. So UVs can be done as a simple front and back projections on the model. It's two circles, basically. So this is best done as a non-square layout because it matches that shape better. So I chose 2048 by 1024. Next is baking the textures from that high poly photogrammetry asset down to this real-time one. And really, there are three textures that I needed to bake here. There's the diffuse texture to bake from the photogrammetry, then the neural map to bake the geometry detail into all this fine kind of bump mapping detail. And then ambient occlusion, that really helps for extra lighting information. It helps to improve your PBR shading. So it's a good thing to bake. So here are the textures. The top left is the end result. And then the first five are all standard PBR inputs, if you're familiar with PBR rendering. The last two are really specific to the iridescence extension. So the strength texture is a simple mask for the iridescence effect, whether it's on or off. And it's full strength on the smooth inside, and then 0 for the rough outside. So it's black out there. And then I added these half strength areas where the animal was connected to the shell and kind of ripped away some of the iridescence there. And then the thickness texture at the end there is to add variation to the thin film. And we'll talk a little bit more about that in the next couple slides, but it's basically just a high pass filter on the diffuse map. It's really simple to make that. So with the real-time PBR asset, it's really best for download size and rendering performance to pack textures together. The top texture there is ORM for short. It's, packing occlusion, rough, and metal into the red, green, and blue channels. Well, the same thing for iridescence. We pack those textures to make it an efficient texture. And we're using grayscale textures here, so it's easy just to pack those into the red and green channels. So then we end up, instead of 7 separate texture files, we end up with 4, which is really efficient. Then we can hook these textures up to the 3D model and export out to glTF. Here I'm using the Babylon JS exporter inside of 3ds Max. Now it doesn't yet support iridescence, it's just too new of an extension. So we'll add that texture after the export. So once exported, we end up with these files. The bin file contains all the mesh data, UVs, vertices, animation, all that kind of stuff. And the glTF file is just a simple text file, so it's really easy to edit. That's where we'll control all the material settings. And then the textures that it generates. The last texture is automatically packed from those 3 input textures. And since the exporter doesn't support iridescence, I packed that separately. You can use Photoshop or Substance or just about any image editor to do that work. So I should mention you can also use Blender. It has excellent support for glTF import and export. And Chronos supports active development of glTF features for Blender. So you'll see regular updates here, which is great to see. However, as with all 3D modeling tools, it's an incomplete round trip. None of them support 100% of glTF features. Now, on the plus side, the new BSDF shader that's in development promises to improve this with support for many of the new glTF extensions. So after exporting to glTF, we can then edit in any text editor. Personally, I prefer Visual Studio Code. It has this great glTF support, especially with the glTF tools extension from Cesium. So it includes this live 3D preview, which updates as you work, and you can choose from 4 different glTF renderers. I find it's really helpful to check my model and just make sure that it looks great in a few different renderers. One of the great strengths of glTF is its portability. So here's the raw export on the left and the finished result on the right, just to kind of give you an idea of the changes that'll happen here. So before we can add iridescence, we need to know what the settings are to choose from. So the official specification comes in handy here, and it lists all the parameters and what they do. The other thing that's great to have is a visual representation. So here's a neat asset that you can tumble around in a 3D Rev viewer. This is 2 screenshots of the same model, just different angles so that we can see the axis labels and kind of figure out what values we want to use for a specific look. So here I've chosen and surrounded one of them with a little box so you can see. Those are the colors that I wanted to use on the inside of the abalone shell. And it's primarily pink and green, and that's kind of the values and the strength that I wanted. So for the x-axis here on this asset, and the top left there, that tells me the thickness should be around 700 nanometers. So I'm going to remember that number. And then the y-axis, which is about the middle of the thing there, says material color. That's actually the base color. And it's going to be around 50% gray for me. And then the z-axis in the bottom middle there is for the index of refraction of the thin film. So you can set that independently. And for this asset, it's going to be around 1.5. So another important thing here with iridescence is metalness. The more metal the surface is, the stronger the iridescent effect. Now, abalone shell is not made out of metal, right? It's an organic surface, but we can take a little artistic license to get the effect we want. So I think of PBR as a set of guidelines. It's not hard rules. It's good things to follow, but you don't need to be 100% precise. So this is two separate models that are separate assets that you can look at. One on the left is fully metal, and the other is the same, except it's just zero metal. So we probably want something in the middle, maybe 50% metal. So now we can start editing. You can open the glTF in VS Code, and it's formatted as a single line of text, which is not too editable, but you can just right click and format the document, and you get a nice layout. Next, we can turn on Alt-G, which or press Alt-G, which turns on this live preview. And there's no iridescence yet, but we can see the model has exported correctly. So one thing we can do is we can load an existing asset that already has iridescence and use the settings from that and basically paste them in. So what I've got here is this iridescence lamp that's from the sample asset repo. We can just copy the material section that has iridescence and basically paste it right into our document. And here I don't need this extras area, which is for Babylon, from the Babylon exporter. I don't really need that because I'm not rendering specifically in Babylon. So as soon as I paste it in, right away it turns red, and glTF Tools has this auto fix that basically adds the extension into the glTF file. So if we scroll to the bottom, there it is, extensions used. And that's just required so that the glTF file knows, hey, I've got iridescence here. And the next thing here is I've got a texture here for thickness, and it's using index 2, but the index is already used by the base color texture. So we'll need to increment that up to index 3. And right away it turns red to tell us, hey, there's no texture 3. So what I'll do is copy one of the textures and paste it, increment the source up to 3, and rename it to be my iridescence texture, the name of the file that I have on in my folder. And it also goes red to say there's no third source. So again, I'll copy it and paste in the file. And here the file name really matters in the images section. That's the actual file name that's on disk. So if I go and look at my folder, I don't have the iridescence texture in there because it didn't export as part of the export. So I'll just copy and paste it into my folder. Then if I go back to the document, add a space, save, now it updates, and I can see the iridescence has been added to the model. So, the iridescence is here, but it's way too strong. So we have a thickness texture, but we haven't enabled the strength channel yet. So if I go in and add a comma and add some quotes, automatically it shows me another factor that I can add, which is this iridescent texture. And here with autocomplete, I can just add the index and say the number of the file, which I know is index 3 already. And it's the blue channel because that's where it puts the strength. Format the document to make it easy to edit. And then we save it and it updates the preview. And now the iridescence is only in the inside of the model and not on the outside. Still, it's pretty strong. So I think it's basically the metalness is too strong. We need to add a metallic factor and set that to half strength. And what that'll do is get it back into a more kind of reasonable value. And as soon as we save the file, it'll update in the view again, and we can see now we have a decent range of values. So the other thing we haven't set is we haven't set the thickness value or the IOR. So here I'm setting the IOR to 1.5, right, which is the value that we saw. And then the thickness, I want to set it to a range of values that's centered around that 700 number that I got earlier. And here, if I choose a maximum and a minimum that are kind of bracketing that number, then the thickness texture will be the gradient between those two values. So I'll get a little bit of extra variation here in terms of adding that effect. And the other thing I can do is look at it in different renderers. So here I'm changing to different renderers to see how it renders. Now, cesium and filament don't yet support iridescence, so it's not showing up there, but at least the model shows up. So something's better than nothing. But that's basically how it works. So let's take a look at the anisotropy model. This one uses the new extension KHR Materials Anisotropy. And I was working at Wayfair when we built this asset, and this is a real product on the Wayfair site. It has this brushed metal surface with a clear coat on top. And the anisotropy comes from the micro grooves on the brushed copper. So anisotropy is great for a lot of things. You can represent anything basically with fine grooves that causes these kind of specular reflections. You could look at, sunshine on a black horse. It's a great example. It's a really interesting way that the sun actually moves across the hair of the horse. Human hair is another great example, or at the bottom of a saucepan, or the grooves on a vinyl record. All those things are impossible to represent properly without anisotropy. So here's the lamp model in the glTF sample viewer. As we rotate around, you can see the reflections are elongating and doing these kind of patterns based on the anisotropy. If we go into advanced controls and turn off the anisotropy, you can see then the reflections turn into more circular kind of shaped blobs, and you don't get that kind of radial anisotropy that you get. So we really do need anisotropy to reproduce this kind of surface and make an accurate product model. So this time we'll use the built-in exporter from Autodesk. A great feature they have is they support many of the glTF extensions out of the gate. So they have clear coat and sheen and specular, transmission, volume, and IOR. Now, again, anisotropy is a little too new. It's not supported yet. So you can see here the pinkish texture there is not hooked up. Again, we'll just add it in VS Code after we export. So as before, we need to make the textures. Most of these, again, are familiar for PBR. New here are the tangent and the bitangent in the top right. Those are channels that are automatically generated on export, but they're totally required for anisotropy. So in order to actually get the exporter to generate these channels, we'll need to make sure that there's a normal bump map, which tells the exporter to generate this channel, this data. And the last two for anisotropy are packed together into a single map, just like with iridescence. The red and green channel are for the direction of the anisotropic stretching, and the blue channel is for the strength of anisotropy. So here are the channels for the anisotropy texture. The red and green channels create a 2D vector to tell the renderer which direction to stretch those reflections. And the blue channel is just a simple black and white mask. But all three are necessary to get proper anisotropy. If you set any of those to 0, like I'm doing in the bottom row there, you'll get the results that are shown there. You just don't get proper stretching. So you'd need data in all three channels. So to figure out which colors to use, I made this chart to kind of help me understand it. With brush metal, we want the lighting to be stretched perpendicular to the brushed grooves. So the ellipses in the center there, the white ones, they show the colors that I'll want to use to get specific directions for the stretching. So if my grooves go horizontal, I'll want either a light blue at the top here or a purple at the bottom. And if we want radial anisotropy, like the bottom of a saucepan, then we'll want a gradient sweep like this. For 0 anisotropy, we can set the blue channel to use black. It's also a good idea to set the red and green to 50% gray, which ends up causing less lighting artifacts. So that's why we get this kind of pukey green color where we don't want the anisotropy to occur. So here it is applied to the model and the UVs that are corresponding to that. Some of the metal parts just don't use a radial brush pattern at all. All the cylindrical shapes on the model have linear grooves. So that's why we use solid colors. And you choose a color that's perpendicular to the brushed pattern as per the diagram that I previously showed. The UV orientation affects the anisotropy direction. So some UVs are vertical, they're colored in pink there, and some are horizontal, so they use the light cyan color. The brush pattern is vertical on the pink ones, so we want the anisotropy to be perpendicular to that. And then on the light cyan ones, well, those are horizontal UVs, but the grooves are actually running vertically. Again, the grooves are running horizontal for those blue areas. So we'll want the anisotropy to go vertical. So when we were designing anisotropy in the Chronos group calls, we looked at what other renderers use for their anisotropy direction textures. And as you can expect, there isn't one unified standard, right? Everyone kind of chooses their own thing. It would be nice to choose something that could be easily converted from other renderers. We thought about using a single grayscale channel sweep like Substance or V-Ray uses, but that we found that creates artifacts where it suddenly changes from 0 to 360 degrees. So we chose a 2-channel gradient, and we chose Y up for the green channel, which matches how OpenGL does normal maps already. But it shouldn't be hard to convert between these if you have pre-existing content, because they're all gradients, right? So they should convert without too much trouble. The other important thing here is the anisotropy has to be normalized. If not, you see lighting errors in the surface. It really depends on the renderer, but it's better to avoid this if you can. And by normalized, it means that each pixel in that anisotropy direction texture has to have a length of 1 when it creates a vector. And so those textures have to be normalized. And thankfully, there's an easy way to do this. So I made an SBSAR and Substance 3D Designer, which you can use in any player that plays SBSAR files. So Max, Maya, Blender, Substance 3D Player even is a free option. And it's important here to normalize only the red and the green channels and ignore the blue completely, because it's a 2D vector, it's not a 3D one. When you normalize, say, a normal map, for example, it uses all 3 channels, and you want to normalize that as a 3D vector. But here with anisotropy, it's a 2D vector, so you only want to normalize only the 2D, those 2 channels. And this graph is available in the README for the anisotropy barn lamp sample assets, so it's easy to get to. The last point to mention here is, if you have fine bump details on your surface, you want to disable anisotropy for those areas. So here you can see some embossed text and some knurling on the grip above it. If the anisotropy isn't masked off, the bump map won't get proper highlights. So you can see in the top left, it is being masked off, and you get those proper highlights, and it looks like it's bumped out text. But in the middle example at the top, it's not masked off. And so you're not getting those little round highlights. So that's the end of my presentation. And here's that end result again to kind of show how these effects actually work on the models. And then I provide also a bunch of links in the slide deck, which will be available after the show here. Feel free to ask questions about the process. I want to hear from you what your issues are with your material workflows and how PBR works, and what you'd like to see in the future of glTF. What are your pain points?
Thanks, Eric. As Eric mentioned, if you have questions, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. Let's go ahead and get started. We have Anthony Datu. He asks, can the texture be a newer image format such as WebP or AVIF file for file reduction purpose?
Yeah, definitely. I mean, WebP is definitely a possibility. I think the limitation I saw with WebP is certainly it makes a lot smaller file, but it also adds noise. So sometimes that noise can get in the way of the actual anisotropy effect, because remember, it's generating a vector for each pixel. So if you add noise, then you're going to add normalization artifacts. Remember, we talked about how sometimes you'll get those pixely kind of shading issues. That can definitely cause problems. So it's kind of up to you, whether you want, whether the file size is more important. It also depends on the texture itself. So I think in my sample asset, I just used PNG files, which are lossless compression, and generally work really well if you have a lot of even colors across the model, because then it compresses really well in PNG. But certainly, I mean, you can make, whatever texture format choices you want. So JPEG, WebP. I haven't looked at AFIF, so I need to take a look at that. That sounds really interesting.
Excellent. Are there artist-friendly editing tools that people can get a hold of?
Oh yeah, so not everyone loves to edit in text, right? I find it super powerful, and I can edit anything that I need to, and it gives me that full control and a bunch of different renderers. So it's great for me. But the other tools that are out there, I mean, there's Gestalter, which is free to use for non-commercial use. That's a great tool from UX3D. They have a whole graphic user interface where you can edit all the material values, add extensions, that kind of thing. Some people find that really great, and I think that's a great tool to have in your arsenal. There's also Babylon.js Sandbox. It has an easy way to edit glTF files. I don't know if it supports anisotropy editing. I think it does. I don't know. We'd have to look and see if the exporter still supports that. But I know they're constantly adding new features to that as well. The trick with Babylon.js is there are a lot of extra features that are specific to Babylon.js that aren't specific to glTF. So you just have to be careful when you're editing that you're not editing things that aren't going to export.
Anthony had a follow up. He said thank you. The reason why he asked is that for newer format is due to 3D assets being delivered via the web.
Yeah, there are a bunch of interesting issues there. Like you can definitely generate, PNG and JPEG are just standard. They render everywhere. But if you use WebP or AFIF or one of these other formats, it probably requires a specific extension. And then you've got to see, does your intended renderer support that extension? That's one feature or one factor kind of consider. Another thing is that when you compress textures for the web, sure, it makes the download size much faster, but it can also make the upload slower, because basically when you upload the 3D model to the GPU, it's got to uncompress those textures, and they become these large uncompressed files in GPU memory in order to render them. So both it takes that process to uncompress them, that can take a little time, and then it also consumes a lot of memory. So if you're rendering more than one model, like say you're doing a room planner, or you're doing a game that has a game level, lots of models, or you're doing a product configurator with you're loading constantly different models, that can really slow it down. So thankfully, there's this format called KTX, which stays compressed both on the hard drive or on the file when you download it, and also it stays compressed on the GPU and memory. So, there are upsides and downsides, right? Like WebP can be really tiny, but it uncompresses completely, whereas KTX can be a little bit larger, but it stays compressed, and it's kind of a trade-off. It's a great question.
New question from Vinny Varghese. How do you create the necessary textures for anisotropy? Is that created manually or using any tools?
Yeah, so my primary tool for that asset was 3ds Max, and basically I just did radio gradients, sweep gradients that are programmatic nodes, right? They're procedural textures, and I applied them with a second UV inside 3ds Max, and then baked that down into my combined UV layout. You can certainly generate that with, say, Substance, Substance Painter, different kinds of tools. I would certainly see that people could do it in Blender or Maya. It just depends on how familiar you are with generating procedural textures and baking them down. And then as far as the black and white mask goes, I think that was just done in Substance. I took the text file, the text that I was using for the bump, and made that into a mask.
Joel Zachariah asks, are there any artist-friendly solutions for KTX? As far as I know, we need to use command line for conversion.
Yeah, that's a good question. We just came up with a tool in the Kronos group that we funded development on called glTF compressor. And we should probably post a link to that. That's a great tool. If you do a search on the Kronos site for glTF compressor, you'll find this great web friendly GUI file that's built on top of the glTF sample viewer. And basically you can just drag and drop your model into there and compress individual textures to glTF. And then, you can see before and after. There's a before and after swipe, so you can see directly on your model what the effect of each setting is. So that's one way to do it, kind of an artist friendly to make KTX files. And then the other way is Gestalter that I mentioned earlier for material editing. They also have KTX compression inside their tool. So it's all very visual and easy to edit.
Shafiq Mohammed asks, why is glTF called as GPU ready file?
Yeah, so one of the design parameters that we have for glTF is that it's really a delivery format. At its core, it's built to be really machine readable, right? Just to be ready for the GPU to ingest readily and render quickly, because it's really meant to be a delivery file to get to the end consumer, right? Get them a 3D model and have it render as easily and as painlessly as possible. So that's like a core design principle that every time we're looking at new features to add, like anisotropy or iridescence or any of these things, we want to figure out how best to make it work in a runtime situation and get it to be as painless as possible for renderers to ingest that file, which is really one of the great strengths of glTF, and means that a lot of people have been able to integrate it into their tool chains and their tool sets, and it's almost become an interchange format as well. It's not really designed to be an interchange format, it's designed to be delivery, but since it's so well kind of specced out and designed very carefully, it ends up working really well for that.
So do these effects translate to USDZ?
Yeah, they don't, right? You can, it depends on what you want to do with the USDZ file. You can, if you want to render just in quick view, like AR quick look, it doesn't support these kinds of effects. But Reality Kit allows you in the Apple iOS, in the Mac OS tool set, you can actually write your own shaders and include them in the USDZ file. And so those will render basically in specific renderers in the Apple ecosystem. But they don't work in kind of the standard quick view or quick look that you get. So you just kind of have to be careful of how you generate that. But it's a little bit extra work. It's not as kind of easy and plug and play as glTF is.
Are there future PBR extensions on the horizon?
Yeah, we are currently working on something called diffuse transmission, which is like when you see a leaf being hit by the sun and the backside of the leaf gets this bright green color. Or, there's some plants that actually have red on the backside and green on the front side, or a different color on each side of the leaf. And so you get this different kind of colored effect of the light going through, or light going through paper, for example, shines through it. So that's diffuse transmission. So that's in development. There's actually a PR that's out right now. So you can actually play with it and test it. And then we're also looking at subsurface scattering. That's probably next on the roadmap after that. And there are a few other things. We're looking at tone mapping and some other formats to add and things like that. So definitely there's a lot of active development on what are people's pain points.
And Shafiq Mohammed asks, when it comes to web rendering, which format is more feasible, glTF or USD?
That's a good question. I think you kind of need both. It really depends on where you want to render to. I see glTF as being much more universal, and that you can render just about everywhere. The trick is if you're targeting the Apple ecosystem of people using iPhones. And there, the system is really designed best to use USDZ as the core kind of default format for 3D. So if you want to hit your customers in the Apple ecosystem, then you need to develop USDZ as well. But USDZ doesn't really easily render anywhere else. So that's where glTF kind of shines. So, it's kind of a toss-up. But you did mention USD, which is different from USDZ. So USD is this full kind of development format for actually authoring content. And that's how Pixar develops their movies that are pre-rendered. And a lot of video effects houses, visual effects houses use USD as a way to keep files together and to do really large, complex tools. But USDZ is this kind of small subset of USD that's specifically for delivery of web assets via the Apple ecosystem.
Anthony Datu asks, is there a command line tool exporter that can import USDZ to glTF format?
I'm sure there is. I can't think of one offhand, but I think there definitely are. We can look into that. I know that there are a bunch of translation tools out there, like I just started at DJG and they support it as part of their rapid compact process. And they also have a command line tool for that. But I'm sure there's stuff on GitHub as well for going from USDZ to glTF.
And Andrew Varga adds gltfeditor.com can convert between USDZ and glTF. So thank you, Andrew. One last question here. How can individuals get involved in the Kronos Group standards development without becoming a member?
Yeah, we definitely provide a way for people to interact with the team. And there's a glTF Slack channel that's great for that has a bunch of separate channels. The Slack, what do you call it? A Slack site. That's I have to find the link, but that's a great way to interact. There's also a Discord for it. So if you go to the Kronos website, they'll have a bunch of those resources for ways to interact. And we regularly watch those things to see, we want to learn what the community is facing and their problems so that we can, figure out your pain points and see if we can develop things to help with those. So yeah, there's some great stuff in the chat. There's some links that are being posted. So yeah, definitely, we welcome people's questions and concerns and issues in those channels to kind of help guide some of our directional assets.
And now +1 your Kronos Discord. It's a wonderful place to interact. Thank you, Eric, for a wonderful presentation. We appreciate all your time and effort. Thank you, everyone, for joining us here today. If you enjoyed today's glTF presentation, please join us for a series of upcoming glTF webinars, as you can see on the screen here. As a reminder, a recording of this presentation along with the slides will be available on the Kronos Group website, and a direct link will be sent to you in a follow-up email. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to help us improve these presentations, and please let us know if there are other Kronos-related topics you may be interested in. Thank you for joining us. We hope you have enjoyed the webinar. Have a great day.
Yep. Thanks, everyone.